All right, welcome everyone. How many of you are here because Victor and Thea's room was full? Be honest. just, just the people in the front row because they couldn't get the good seats at the back, right? That's fine. I would have loved to go to Victor as well, but I was otherwise engaged. So I give a couple of speaker mentoring classes where I mentor starting speakers to start a career as speaking at conferences. And in those classes, I tell participants that it's fine to submit multiple proposals for conferences. So the organizers have to pick something. But you should also be prepared for the risk that all your talks are accepted and that you need to go present. So I warn people for that. So I haven't listened to my own warning because this is my 7th talk in 1 week in 2 continents. So that was a bit much. So I can use your support to get me through this talk. So, you know, whatever you want to do, shout, stand up, wave, it's all good for me. So let's talk about software architecture decisions, and hopefully good ones. So I've made my fair share of bad architecture decisions in my career, and I hope to prevent you from making some of the same mistakes as I did. So I'll start with a story about a wrong decision I made, and this story involves an amazing technology. It starts with an X, like all my amazing technologies, but this is XSLT. How many of you have worked with XSLT before? Okay, keep your hand up and put it down. Well, keep it up if you liked working with XSLT. We have one. I kind of liked it, but not really. So this was for a project where we needed to convert loads of data from XML to JSON. And a team of 3 people had the task to build this conversion, and we're talking, I don't know, at least hundreds of megabytes of XML. And well, I was working as an architect there, and I wanted to give this team somewhat the freedom to make their own technology choices, because who doesn't hate the fact that the architect says you should do it this way and you totally disagree? So I said, okay, well, what do you want to do to solve this conversion problem? And I said, yeah, I want to use XSLT. And I said, okay, that's interesting. So why do you want to use XSLT? Yeah, well, because the input is XML, and XSLT is for transforming stuff, and we're all pretty good at XSLT, and we think it's suitable for the job. And I said, okay, but how about other knowledge in the company and about XSLT and performance and maintainability? And they're like, no, that's all not a problem at all. I said, okay, I don't want the person to dictate what you do. So if you want to do XSLT, by all means, go do XSLT. 1 week later, one of the 3 left. So now we had 2 XSLT developers. And then about 2 months later, they came to me and said, yeah, we're a bit of in trouble because, well, it's not performing too well. And some of the constructs we want to migrate, they don't really work too well. So, but we're going to make it. So then 1 week later, one of them called in sick because he couldn't deal with it anymore. So then we had one, and 1 week later the project stopped, and we ended up throwing everything away and rebuilding it in Java with Sex or JXP and JSON and Jackson, those kind of things, which you would usually do from the perspective of a Java developer. So what I did wrong there is I focused a bit too much on freedom and independence for the team. And I didn't pay enough attention to some of the non-functional, so stuff like performance and maintainability, or also the organizational constraint of having knowledge about actually developing in the chosen technology. So this talk should give you some guidance to making some of these decisions yourself. So my name is Bert Jan Schrijver. I'm CTO at Open Value, which is part of Tech Tribes, a platform for specialized IT companies. And I'm also in the NLJUG, the Netherlands Java User Group. So do we have any members from the Netherlands Java User Group here? Yes, all right. So did you all get your JFL ticket? Okay, so we have some happy people here. We sold out in a couple of seconds or something, I believe. I'm also involved in the ISAQB, which is the International Software Architecture Qualification Board. The ISAQB has a booth here downstairs where I'll be for the rest of the afternoon. So if you want to talk software architecture, please feel free to join there. The ISAQB arranges software architecture trainings, for example. So, let's talk about software. You're all software engineers, right? Are you? Okay, good. You write software every day? Some of you know we have stand-ups and, I don't know, you know, design sessions and product increments. So ask yourself the question, if you're a software engineer, ask yourself the question, I'll give you some time, what is software? Magic. Magic is just a word for something non-trivial that you do not fully understand. But that the same concept applies to software, I guess. Well, you could say something like it's instructions that tell a computer what to do, or it's code and algorithms and data, or the part of the system you cannot kick. That also works. And an important concept of software development is software architecture. So let's ask you this question, what is software architecture? Boxes and arrows. Boxes and arrows is a part of software architecture, I agree. So whenever I want to know what something means, I ask people who know what they're talking about. For example, Martin Fowler says that software architecture is those decisions that are both important and hard to change. Dave Farley says that the guy from the continuous delivery book, he says that software architecture allows you to build systems that are beyond the scale that you can hold in your head. Now, I have a fairly large head. Whenever I go to the kart racing track, I need to get the XXL helmet, but still, not all systems fit in my head. And then Grady Booch, who introduced himself as the UML guy, but he did more than that, he says that software architecture represents the significant design decisions that shape a system, where significant is measured by cost of change. So if something is expensive to change, then it's probably a significant decision. To give you an example, if you're building a house and you need to choose whether you have a red or a yellow chimney on top of the house, if after 2 years you get bored of the chimney, you can lift it up and put a new one on there. It's not super expensive. You need a crane and stuff, but it's doable. But if you need to decide whether you get a concrete foundation or a bamboo foundation, well, that's a significant design decision, I would say. So the definition that I like is that software architecture enables a team to build software that provides solutions for business problems. But also that software architecture is about making decisions by solving contradictions, basically. So now that we know that software architecture is about making decisions, how do you make decisions? Those significant decisions, the ones that are both important and hard to change, the ones that hurt if you get them wrong. For example, should we go microservices or something else? Which framework to choose? Which runtime, which cloud provider to run on? How do you make the right decision? Well, I'm a consultant, so I'm going to say, it depends. So I did another talk a while ago about making design decisions, and I was explaining loads of things, and at the end I said it depends. And then I got the review. Yeah, talking for an hour, and then the answer is, it depends, I'm not happy. So hopefully this talk won't end with depends. But whenever somebody says it depends, which is fine, which is fair even, you can reply with, on what, right? To train you into doing this from now on, every time from now on I say it depends, I want you to shout, on what? Loudly, okay? So loud that, that I get scared. So let's see what those decisions depend on. Let's start with bad reasons for architecture decisions. We've always done it like this, so we should do it in this way. Well, you could say that this is somehow conformant to the architecture you have, but if you've been doing it wrong for forever, then you keep doing it wrong forever. We don't want to depend on this library or this cloud provider or whatever. Sure, probably as a small company, you're better at writing an encryption library than whole of the internet in the open source community, right? So not really a good reason at all. We need to be future-proof. Well, last time I checked, we couldn't predict the future. So in order to be prepared for any future change, the only thing you need to do is make the system as simple as possible, because then it becomes relatively easy to change. Because the product owner wants it. Product owner wants to do it in this way. Well, product owner can tell whatever they want about what we should do, or maybe how it should work functionally, but we, the team, decide how it will work technically, because that's why we're the development team. It says development, and the product owner is the product owner, which is the product side. And then my favorite one, a bad reason for architecture decision is because the architect wants it. So whenever somebody does this, you can call my friend. My friend's name is Benny. Benny is a seagull. So whenever a team does something because the architect wants something, the architect is practicing seagull architecture. So to explain what seagull architecture is, envision yourself that the development team is walking out here, nice sunny day on the boulevard on the beach. They're discussing their next design decision. They are having French fries. And then there's an architect. But the architect is not down on the beach. The architect is soaring high to the skies. He's over here, right? He's looking down at the peasants of the development team. Every now and then he flies down. Ah! He flies to the team. He drops his shit on the team. Wait, he steals their French fries and then flies back up again, right? This is seagull architecture. So the problem here, wait, one more thing, and then you can upload. The problem here is that the shit is only going down, while the shit should be going back up again to the architect. Thank you. I didn't practice that running up the stairs. So Benny, seagull architecture. So how do you make architecture decisions? Well, it depends. On what? Yes. Well, I'll share some input that you can use to make those decisions. The first one is the 5 W's. And they're quite difficult to remember. So I explain them clearly to you. The first one is why. So somebody wants something, I want to do, I don't know, event-driven architecture. Why? Why do you want to do event-driven architecture? Well, then you get an answer, but it's probably not the final answer, right? So then the second W, this is easy. This is why. So why do you, because I want performance. Why do you want performance? And then the third W, and this is the most difficult one to remember, and it's also fairly unpredictable because this is why. So you keep asking why again. Why do we need performance? Well, because we have at least 100 concurrent users. Okay, then the fourth one is easy, that's why. So why do we need an event-driven system for 100 users? Well, because they're going to do at least one request per minute. And then the fifth W is why. So why do we need an event-driven system for 100 users with one request per minute? Because that's basically like one request per second for 100 users in total or something. So keep asking why until either you get to the real point or the person has no answers anymore and they just walk away. So why are we even here as architects or as software developers? Well, why are there jobs for architects? Well, to enable one or more teams to build something. So let's apply the 5 W's and start with the first one. So why? Why do we want teams to build something? To help a business reach their goals. A business has a goal, usually making money, and software can assist them in reaching that goal. So why does a business want to reach their goals? Well, because that's why we even have a job, right? So business hire architects to make sure that they allow teams to build stuff that makes the business reach their goals, but makes them make money. So that, I don't know, the owners of the 2 large corporations in the world can basically swap places in who's the richest person in the world, right? True story. But as a result, every architecture decision has a business component. And as technologists, we are, I don't know, inclined to look at all the cool tech stuff. But we're not doing tech stuff for tech. We're doing tech stuff to enable business to reach results. So those business arguments, they matter just as much, if not more, than the technical arguments. So what could be input for architecture decisions? Just shout something so I can drink a little. Requirements, yes, good. And what type of requirements do we know? Functional, non-functional, yes, we call them non-functional. You can also call them quality attributes because they describe desired qualities of the system. There's this one, and well, there may also be constraints like time, money, skills, legal, GDPR, licensing, I don't know. And then ask yourself, which of these types of requirements impacts our architecture the most? But maybe it's easier to reverse this question and ask yourself, which of these types of requirements or constraints impact our architecture the least? What do you think? I would say the functional requirements, because a functional requirement usually says like, okay, there's a button here and you click there and then this happens and this happens. While the non-functionals can say, we need to have, I don't know, a P99 of 100 milliseconds on every response time or something. And this will influence how you design your system, the infrastructure, etc. The color of that button, not really. Constraints can also have a huge impact. Yes, I'm going to design this new event-driven Java system. Oh, I guess our COBOL developers will love building it. So realize that we can never fully fulfill all these requirements. And as a result, we always need to consider trade-offs between those requirements and those constraints. So first, let's talk about those quality attributes, or those non-functionals. How I like to explain non-functionals is, it's a difficult sentence, but non-functionals are those requirements that if you do not meet them, they make the system non-functional. Like availability, performance, those kind of things. They're also known as the ilities because most of them end with ility. So what quality attributes and non-functionals do you know? Just shout. All those ilities, right? And then nobody dares to say performance because it doesn't end with ility, right? So stuff like performance, security, availability, reliability, in general, everything that's in ISO 25010, which is a standard for product quality that's been around for ages. You can see it in the layout how it looks. It looks how it was designed in 1982, which probably is true. But there's actually value in this. So you can look it up at ISO25000.com. You'll see this table, and there are loads of different categories. The categories are functional suitability, compatibility, reliability, and there are subcategories in any of them. And I like to use this as sort of a checklist to validate that I've thought about the significant things for my software architecture. For example, time behavior. So how fast does the system respond in milliseconds? Resource utilization, how many resources, CPU, memory, disk does it use? Capacity, what's the number of requests or users the system can handle? Operability, how easy is it to operate from, let's say, a maintenance or operator perspective? Self-descriptiveness, do you need a training to use it or can you use it right away? I remember building a system for a government organization and then a project manager came and said, oh no, we need to make training to use the system. I was like, why? Yeah, because that's what we do. And I said, have you ever had a training to use Google or Facebook or Instagram? No. Okay, so maybe we should make the systems more self-descriptive and easy to use, right? Availability, like does it work when you need to? Can it handle errors? Can it recover from those errors? So I don't know, your database connection fails and the database starts up again. Do you now first need to drain your connection pool or does it automatically reconnect? Confidentiality, will you not get in the newspaper? Integrity, will your data not get corrupted? Modifiability, can you change it? It's also called maintainability. Can you test it? Can you scale it? Well, loads of things with descriptions also what it means, and these help you think about the things that you didn't think about. So which of all these requirements or constraints are the most important? Well, that's easy. It depends. Yes, on your business. Basically, well, everything is different for every business, and every business has different priorities. So you need to prioritize. But how do you prioritize? Well, this is where trade-off analysis comes in. So trade-off analysis for software architecture is a way to make decisions on different solutions and compare them to your requirements and to figure out which solution fits your most important requirements the best. If you've ever heard of ATAM, Architecture Trade-off Analysis Method, it's pretty much the same thing, but a bit more old school. So in trade-off analysis, you start by gathering requirements, by quality attributes, by constraints. Then you start thinking about your solution space. So given the problem that I have, how many different solutions can I come up with? Microservices, event-driven, service-based, space-based, those kind of things. Then you start discovering the trade-offs that are there. So you start plotting your requirements, maybe even prioritized, to those different solutions, and you weigh them. How well does this solution fulfill my requirements? Then you pick the one that fits best. Then you document it, so you write it down. And afterwards, it's also important to validate that the decision you've made actually fulfills and still fulfills the requirement. So most of this is described in a book by Neil Ford and Mark Richards, Software Architecture, The Hard Parts. It's a good book to read if you want to know more about the stuff I'm rambling about. So what is a trade-off? I was at Dev2 Next last week in Colorado, the conference that Venkat Subramaniam organizes. And there was a talk by Michael Carducci, and he showed this. And he said the trade-off is basically you have a scale. On one hand, you have what do we get, and on the other hand, have what do we have to give up. So you cannot have everything. So there's always things you need to give less priority, you maybe leave out in order to get to a balanced architecture. So examples of trade-offs are, for example, security versus usability. Can you give me a 3-letter abbreviation that demonstrates a security versus usability trade-off? MFA, or 2FA even, yeah. Who loves MFA from a security perspective? Who loves MFA from a usability perspective? That's a trade-off. There are some people who love grabbing their phone and typing codes in there. That's fine. Configurability versus maintainability. If you can configure loads of things in your system, then you may have lots of permutations in your code paths, and it may be more difficult to maintain because you may need to test all the permutations of all configuration options. Availability versus cost. I want to have 99.99% availability. What I usually say to people who tell me this is every 9 you add adds a 0 to the infrastructure budget. And because you need, first you start with one server, then you need 2 servers with a load balancer, then maybe you need multiple availability zones, multiple regions, maybe multiple cloud providers, but then you need something in front that switches between those cloud providers, and now this needs to be on 2 servers, and basically you can keep going there. Making stuff super available, super expensive. Performance versus cost. If you want performance, sometimes this also makes stuff more expensive, either because it's more difficult to write or because you need more hardware. So an example here is I was building a web-based project with a front end and a back end, and we were doing like load tests every sprint. And right before we went to go live, we saw that one piece of functionality was twice as slow as the sprint before, or actually it could handle only half the amount of concurrent requests that we had before. So we needed to go live. So we decided to go live and scale to twice the amount of servers. We went from 4 to 8 or something. But yeah, there was a performance issue, so we wanted to investigate. So we went to the product owner and we said, yeah, there's this issue. We don't know what it is, but it's a performance issue. And as a result, we are now running on 8 servers instead of 4. And we would like to get some time next sprint to investigate. And then the product owner said, okay, I understand. So how much time do you need to investigate? Well, yeah, probably 2 days with 2 people or something like that. So it'll be like 32 hours. Okay. And how much is this extra infrastructure costing? Yeah, it's at least 200 euros a month. Okay, so I can choose between paying 200 euros a month or paying like 32 hours, let's say 3,200 euros now to have you solve it. And will you be sure that you've solved it? No. And then I lose 32 hours of my product development. So I'm happy to pay this 200 euros for a couple of months. So we were angry, of course, because it was the wrong solution, because we wanted to do engineering and solve performance problems. But from a business perspective, it was fine. 1 day later, we found that we accidentally had removed the cache somewhere doing a call twice, and we solved it in 1 minute. So yes, the product owner was right. Too bad. Performance versus maintainability. Making something that like super high performant may be difficult to read, difficult to maintain. And also runtime configuration versus robustness. So if you can change the Java class in your property file that points to the JWC driver, you make a typo, maybe not so robust. So another short example of a trade-off, the OV fiets. So for those who are not from the Netherlands, the OV fiets is a yellow bicycle you can get at pretty much every train station. and you can use it with your train card, and then you get a bicycle, and you can bicycle anywhere, and then bring it back at any station, if they are available, which they are never. But still, good story. So before those bicycles, you would go to a person, you would show your train card, and they would give you a key and a bicycle. But recently I saw that this was changed, and there's now an automated lock on there, where you tick your card to, and then it unlocks, and there's probably like a GPS in there and a 5G SIM, and you don't need people anymore. And I found this an interesting to see, because having those people there on those bicycles, super low tech. What does a regular bike lock cost? Maybe 20 euros or something. What would an automated system like this cost? Well, you first need the hardware. There needs to be like a card reader in there. As I said, probably like a GSM modem, a SIM, a GPS. This all becomes pretty expensive pretty quickly. And then you need to develop a system that hosts the back end, that can track all those bicycles and stuff. So is this really worth it? Let's say that this is not about getting rid of the people in the train stations, but only about tracking where those bicycles are, because they get stolen all the time. What would be a cheaper alternative to tracking bicycles instead of building a system like this? €30, right? So probably it's not only about tracking lost bicycles, but it's a trade-off between paying all those people in those train stations versus, I don't know, paying hardware and paying a system to maintain those things. And probably also from a usability perspective, it may be, for me, it would be a benefit that I don't need to talk to a person and just hold my card to the bicycle and get going, right? But that may depend per person. I think we can say that the essence of software architecture is to be able to objectively analyze trade-offs about solving conflicting requirements. If you've made a decision where you found something that isn't a trade-off, probably you're just not aware of the trade-off yet. So let's look at an example of trade-off analysis. And this is from a talk by Neil Ford, Modern Trade-off Analysis for Software Architecture. And Neil states here even that everything in software architecture is a trade-off. So he presented this talk at a meetup I organized. And this is a recording from a conference a while ago. So the example that Neil gives, and I talked to Neil last week, and he was okay with me showing his slides to you, just so you know, that I don't get in trouble. An example of this is we need to choose the architecture for our next system. And we've come up with a solution space of 4 different architectures. Microservices, service-based, so kind of like SOA, event-driven with some kind of consumer producer in there, and space-based architecture. How many of you know space-based architecture? No, it's not super well known. Well, it's not known at all, looking at you. I only learned it by watching Neil's talk. So space-based architecture is aimed at achieving basically linear scalability, and it's accomplished by distributing both processing and storage across multiple servers, or maybe across each server, and then you create somewhat of a distributed grid. So the image is a bit small, but you can imagine that on every microservice you have, there's also shared storage and shared database, and the storage and database are synced over these nodes in a somewhat low latency way. So every service can read and write to its local database while not having to worry about, I don't know, communicating to other servers. It's kind of like service mesh alike. So let's say that we need to choose which of these four we're going to pick for our new system. So what we can do is figure out which requirements matter to us. So maintainability, cost, deployability, fault tolerance, simplicity, etc. Then we can start plotting. So this is obviously subjective, but what you can do is look at all those requirements and then discuss with a team, maybe a team of developers, architects, some people from the product side, how well does this architecture fulfill this criterion. We can debate about the number of stars here for hours. These are Neil's stars, and I agree with most of the things that Neil said, but let's not debate about this. But let's assume you've done this. So what you then can do is figure out in which category, which potential solution wins. So you can draw lines around them. So, okay, I've drawn lines about everything that has 4 or 5 stars. So looking at this slide, which one is the best? The answer is simple. It depends. On what? Yes. On the requirements that matter the most to the business. So let's have a look and assume that in this case, maintainability, deployability, and testability was important. In that case, in this specific case, microservices win as an architecture because the three requirements that matter the most to the business are fulfilled the best or to the highest level by this architecture. If you do this yourself, you can also, instead of stars, you can also work with weights. So you can give each requirement a certain weight if you feel that certain requirements are more important than another. And then, for example, you can say that maintainability has weight 2 and the other has weight 1.5 or 1.2. And then you can multiply the score with the weight to, in the end, get like a sort of objective result. So, which types of requirements and trade-offs should you consider? For example, choosing a new architecture or choosing for Spring versus Quarkus or Kotlin versus Java. Now, usually somebody starts shouting Kotlin, but we'll talk about that later. Well, you can look at the relevant quality attributes. We've done this. ISO 25010, go there, you're good. But there's also lots of less technical factors that you need to consider. So, and these are mostly for choosing new things that you don't have in your organization yet, right? So you're going to choose a new framework, a new library, a new cloud provider. So for example, developer experience. How good is the developer experience? Do people actually like to work with this? What's the learning curve? How easy is it to learn? If we needed to choose, if learning curve was important for us and we need to choose between Kotlin and Scala, what would we choose? I told you people were going to shout Kotlin, right? But I agree. Kotlin is a lot easier to learn. I think this is also the reason why Kotlin became pretty successful. How was support in tools and IDEs? Do the tools we have support this new thing? Or do we need to get something new? How about documentation and support? If it's a super new niche framework, there may not be 100,000 GitHub issues or Stack Overflow things, or I don't know, LLMs haven't been trained on it yet to give you answers. How does it integrate with our current landscape? Yeah, we're doing this new event-driven stuff. Does it also have an FTP server interface to, I don't know, talk to our Kix mainframe? Conway's Law. So Melvin Conway said that a systems architecture will form itself basically as a result of the organization structure. It will be in line with the organization structure. So knowing this, you can also reverse this. And if you want to make a technology choice, you can have a look at how is the organization structure. Let's say there's 3 teams and they don't want to work together at all. Should you give them a shared GitLab or a shared Jenkins instance where if one job fails, the others will get bothered by it? No, probably not. So also look at how does my organization function and don't use technology to force people to work together when they don't want to work together. And how about adoption and popularity and expertise? Both in our own team, do our people already know about this or do they really want to learn it? But also in the industry. So if you work with a niche framework, I work with Vertex for years, but we were probably the only company in the Netherlands doing a lot of things with Vertex. So it was quite hard to get developers who wanted to learn. But actually, I remember one developer who joined us and after 3 months quit again because he found that his learning curve wasn't quick enough. And how about long-term viability? So is it being actively developed? Is there a company behind it? Is there a community, an ecosystem? If you take something now where the last commit was 2 years ago, well, then you may get in trouble when a new security issue surfaces there. And then business. Yes, business always needs to do something as well. For example, talk about money, right? So how much does it cost us to run this? Do we need, I don't know, specialized servers from a big 3-letter company to run the COBOL mainframe, or can we go on commodity hardware? Do we need to buy or pay for licenses to use this technology? I don't know, I want to generate PDFs. Suddenly the licensing structure changed and now I need to pay a company to use this PDF generation library. Theoretical story. Support. So can we get support? This would depend on which company you're in, right? So some companies would love to see support as a sort of insurance and get support licensing and support contracts so people can help you. I think if you have good engineers, then probably you can do it without support, right? Engineers. So if it's like a super niche framework, engineers may be more expensive to hire because they know their expertise is scarce. And in end, this ends up to the total cost of ownership, right? How much will it cost me to build a system with this technology in 5 years regarding all those things? How quick will this lead me to market? If you're able to buy something that will skip you 3 months of development time, well, maybe a good idea. This one is always difficult. So I have something and it's not working, and I can do 2 things. I can keep struggling and put it live, or I can throw everything away and then start with something new, and then everything will be fine and will be really fast, right? This decision is quite difficult because you know what you have now. You're pretty clear about how much time it will be to fix it till the end. It will be horrible, but still you got a reasonable prediction. Obviously, developers would love to throw the horrible old stuff away and build something completely new, but there are also lots of unknowns in there. So both known unknowns, the things you know you don't know, but also unknown unknowns, the things you don't know you don't know. And this is why it's quite difficult. And then there's also, after we're done, how much better will it be? Yeah, we throw everything away, we rebuild for 3 months, and then everything will go faster. Yeah, what do you mean faster? Well, then we spend 3 months, and then we can do features in a week instead of 2 weeks. Okay, so for one feature, I need to now wait 3 months and 1 week in one case, or 2 weeks in the other. I'll just go for 2 weeks and let the developers suffer. Obviously, happiness is also a factor. That could also be an organizational factor. Productivity, so does the new thing make you more productive? And then stuff like regulatory requirements, so laws and GDPR and those kind of things. Legal stuff, watch out with certain licenses, right? If you use a viral open source license, you need to make your own stuff open source as well. Some risk on intellectual property. If you use something, so you pay a company to use something that's their IP, and they have like, I don't know, yearly subscriptions. What if that company stops, or they don't want to sell you a subscription anymore? Then you need to be quick to move away from their stuff. And talking about moving away, also think about an exit strategy. So what if at some point in time we don't want to use this anymore? People often talk about vendor lock-in. We were going to go on Amazon, but we're not using any of their cool stuff because we don't want vendor lock-in. So instead of using the Amazon Container Service or the Amazon Kubernetes Service, we're just going to spin up a VM and run our Docker stuff on there. I call that stupid. Because there's amazing stuff that those cloud providers offer that make your life a lot easier and make you even more productive. So I like not talking about vendor lock-in, but I like talking about the cost of moving away. So if I go to Amazon and my deployment service is a Docker container, I can throw it at ECS, at EKS, I can throw it wherever. If for some reason I want to move away from Amazon, I can go to any other cloud provider that offers Docker as a deployment service, which is every cloud provider. I'm still pretty much good to go. And then I can use the amazing stuff that's in ECS or EKS or whatever. So how do you figure out which trade-offs matter? Well, talk to your people, talk to the business, talk to stakeholders. And well, they'll probably start with saying that everything is important. So also force them to choose. I once had a discussion with a protocol owner and he said, yeah, I need you to build this and this. I go, okay, what should I do first? No, both. I said, no, I want you to prioritize them. Okay, they're both prioritization 1. I said, no, prioritization is a one-dimensional list. He means, what do you mean with one-dimensional? I say, there can be only one on top. Okay, then do this first. So force them to prioritize. And what also helps is to take the architect elevator. And this sounds amazing, like there's a specific elevator for architects in the company. Usually there is not. This is a concept from Gregor Hope, who blogs on architectelevator.com. And what Gregor says is, as an architect, you should be able to take the elevator and go to every floor in the building. So go to the engine room in the basement, talk to the engineers there. You should be able to talk to, I don't know, product people or marketing, but also go all the way up and talk to the board. Talk to the CTO, the CISO, the CEO, the CFO. Let's say you want to do continuous deployment. You go to the developers in the basement. Developers are always in the basement, right? No light there, just gremlins typing. I want to do continuous deployment. This will allow you to make small changes and go to production right away. You don't want to deal with deployments, fine. Go talk to the system administrators. Okay, continuous deployment, you don't need to do those manual deployments anymore. We'll automate this and you can focus on the good stuff, like hitting developers with sticks if they did something stupid. All right, then you go up and you go to, I don't know, the chief head of product and you say, yeah, continuous deployment means that we'll be able to get features out way faster and we'll be the first to hit the market. Then you go to the CFO, you say, continuous deployment, this saves loads and loads of money, so we'll be super cheap. Then you go to the CISO, you say, continuous deployment, we will be able to fix security issues in seconds. And then you go to the CTO, you say, hey bro, continuous deployment, you know it's awesome. He understands you, he says, yes, it's awesome. And you say to the CEO, I talk to everyone else and they agree. CEO says, I'm busy, but I think it's a good idea. But figure out what matters to them, because you can only convince people if you know what matters to them. So I gave this talk a while ago, and afterwards somebody came to me and he said that, yeah, can you help me convince my architect that we need to move to Kotlin? And I said, sure, so what did you do? Yeah, it's so weird. I told him that Kotlin is just better and he doesn't understand me. To an architect, what maybe matters is that developers will love it more, that you can be more productive, that there's a big company behind it, that there's lots of framework support, and that you can make super modular applications, whatever. But figure out what matters to somebody to convince them. If you want somebody to fall off their chair, you first need to know on which of the chair's feet they're leaning before you start taking your saw and sawing out one of the feet of the chair, right? So when do you not compromise? You do not compromise, at least from my point of view, when you're risking irreversible damage to your business. For example, security or privacy or huge outages. To give an example, I once had a case where a product owner came to me and they said, I want you to build this and this so people can choose, I don't know, let's give an example that it was an educational publisher, right? So this person came to me and said, I want teachers to choose to which school they belong and then choose to which group they belong. And I said, why? Yeah, because we don't have this information. And when they first enter the system, I want them to choose. I said, okay, but what if they choose the wrong school? Yeah, then they just need to choose another school and choose the right group. But what if then they I don't know, they go to the school where their nephew is and they connect themselves to their group and they see all their results. Yeah, they just shouldn't do that. I said, well, that's you can also say you shouldn't do that to hackers, but they don't listen, right? So if we do this, we will be in the newspaper that we're leaking the results of all the students. Yeah, I still want you to build it. I said, okay, I don't feel comfortable building this. I still want you to build it. Okay, I will build it under one condition. You bring me a note. The note is signed by the CIO of the company, and the note says, I, the CEO, accept that we will build this and this, with the risk that every teacher will be able to see all the results of all the students in the entire country, and that we'll probably get into the newspaper. Was signed, CIO. Problem solved, right? So whenever somebody does this, make it somebody else's problem. Have somebody up a higher rank sign off that this is a good idea. If ever it happens, you can say, oh, CEO approved it. Another example, does anyone of you drive a Volkswagen? They did well in those emission tests, didn't they? So Volkswagen did a trick where I think cars would behave different during an emission test and then get better emission scores, and somebody found out and Volkswagen got in trouble. So what happened here is that managers told engineers to do this. This is fairly unethical, I would say. But the engineers who did this, they went to jail for doing something illegal. So be aware that if you do something that your manager tells you that is illegal or unethical, you are the person that goes to jail. Probably you'll be there together with your manager, but you'll be in jail anyway. So be careful there. So to wrap up, two more topics. One is about documenting architecture decisions. So I usually see two types of documentation. The one is project documentation. Project documentation is documentation for a project that's in motion. You describe what the end result should be, how you're getting there, maybe requirements, maybe some process, maybe some architecture decisions. but you're writing about the desired state of the project in a couple of months from now. And then once this is all done, then you move on to system documentation. So system documentation describes the system at rest. And the goal of system documentation is to allow people to onboard on your project, new people. So this system documentation says, this is the system, these are the high-level components, here is the manual to get you started on the project, here's the design decisions we made, etc. So what often happens is people write project documentation, plans and project start architectures and tickets, and then project is done, and then boom, project documentation is now system documentation. But then you have a big pile of rubbish of stuff describing how the system should be and no documentation about how the system is. So be conscious about this. Because what happens when you don't document? Well, new person comes on the team. Hey, why are we doing this in this way? Well, because of this. Yeah, but why are we doing it in this way and in this framework? And then you can keep explaining the same thing over and over again every time a new person joins. Lovely. So what you can do is write an architecture decision record. An architecture decision record is a piece of text, usually a text file with a couple of things. It describes the title of the decision, the context, so what was the situation in where we took this decision. And this is important because you always take a decision within a certain piece of context, within a certain piece of information. The status, is it proposed, is it final, or it can also be superseded, if there's a new decision superseding this one. The decision we made, and the options we considered. So basically you describe your problem space, your solution space, the context and the chosen decision. And also the consequences. Now we've chosen this, we need to train people in X, Y, Z. Just Google ADR and you will get 1,000 of these templates for this. So now, next time a person comes in, hey, why are we doing this? Oh, go look at the ADRs. Yeah, I've looked at them, but we should do this. Okay, so is this a new option of the options considered? No. Did the context change? No. Did the consequences change? No. Okay, then there's no need to revisit that decision. Yeah, but you can read it again if you want. So working with ADRs is write them for those architecturally significant decisions. Store them in a central place, could be right near your code or maybe a central Git repository. You may have overarching decisions that span multiple projects or project-specific decisions. What I usually like to do is have one Git repository that have all decisions, and then one on like overall overarching decisions, and then maybe a subfolder per project. But then at least you can easily search through all decisions. They are immutable, so don't go changing them afterwards. But if you change your mind, then you write a new ADR, you write this supersedes the previous ADR, and the status of that one becomes superseded. And encourage others to read and write them, otherwise it won't work if you're the only one. So tools you can use here, there's adr.github.io, there's Nick Price has ADR tools on GitHub, and I learned this from Venkat last week. A log for brains from Tom Vail is also like a nice command line utility that you can use to create ADRs. Final topic. Validating your architecture. So once the system is done, how do you know that it conforms to your ideas? What often happens is you write something down, people build it, you look at it a year later, nothing close to what you designed. So once development starts, how do you know that the system stays in conformance with the stuff you designed? Now, this is where fitness functions come in. So I think the term fitness functions was coined by Rebecca Parsons, the former CTO of ThoughtWorks. And this fitness functions come from evolutionary architectures. And it's basically, you could see it as a unit test for your architecture. So a fitness function provides an integrity assessment of some architectural characteristic. So any of those things, the non-functionals, the constraints, any of the things we looked at, a fitness function validates this. So yeah, a unit test for architectural characteristics. So examples could be that, well, we now have 17 violations of X. Could be code duplication or, I don't know, unit test coverage, or, I don't know, we're out of the P99 response times. Any of the stuff you wrote down can be here. So, well, we're in 17, but we have a tolerable range of 20. We're fine, but maybe let's talk about how we can change it so that next time we can lower the threshold to 10. Or maybe dependencies between modules, like cyclic package dependencies, whatever. We found 2, and we don't want them, so we must remove them. So fitness functions are basically guardrails that enable a continuous evolution of your architecture with a range and a direction. And you desire and define that direction. So you can automate them to some extent. Not everything is possible to automate. For example, maintainability. How do you automate this? Maintainability is, I don't know, 3 or 42. But there are stuff you can do. So there are unit tests, well, arc unit tests. So with arc unit, you can define rules that evaluate the stuff in your code base. You can do load tests with, I don't know, Gatling or any tool that verify like performance. You can put alerts on your metric and monitoring, like on errors, on response times, authentication failures, and well, whatever you can come up with, right? So in general, it's advisable to define non-functionals in a way that they're easily measurable, because if you can't measure them, you can also not validate them. So when you're defining those non-functionals, think about this already. And what Neil Ford says, what I like, is that the failing fitness function is not something that should be like a blocker for the team. It's a conversation starter with the team. Hey, I see that you're not conforming to this and this we agreed. Why is this? Were you in a hurry or was something else wrong? So not immediately get angry or hit people, but a conversation starter. So, to summarize. Making those decisions is about gathering requirements and constraints, brainstorm for your solution space, consider different factors, technical, organizational, business. Discover the trade-offs that are there, weigh those trade-offs, pick whatever fits best given the circumstances. Document it so the new guy or girl won't be asking why we're doing this, and also validate it afterwards through fitness functions. So, how do you make architecture decisions? It depends. On what? On the informed trade-offs that you make. That's it. I hope you go kick some ass with your newfound knowledge. Thank you. I have 2 more things. If you have any questions, I'll be at the ISAQB booth downstairs for the rest of the day. Feel free to drop by there. Let's have a chat. I run a software architecture community meetup in the Netherlands. You can join to meetup.com/ISAQBNL. They're usually around Utrecht. Topics like this. Worst case, boring evening with free food and drinks. So it's definitely advisable. Thanks a lot for your time. Don't forget to rate this talk. Be honest, but also be generous. Thank you.